In this video, we'll be doing an example problem looking at the equivalent resistance of a simple segment of resistors. The first step in doing this is to identify which resistors are in series and which ones are in parallel. Now we have 4 resistors here, and the thing I want to note is that only 3 of them are currently either in series or in parallel. Here, the 10 ohm, the 30 ohm, and the 5 ohm are all in parallel. I know this because the current running down through this circuit will split and either have to go through the first, the second, or the third, and then rejoin up together, cannot go through both, and the current splits right beforehand and rejoins right afterhand. And that's what it means to be in parallel. In terms of voltage, it means that they have all the same voltage on one side as the other side. So the first step we're going to do is draw a simpler circuit. And I'm going to label these resistors 1, 2, 3, and 4. And I'll first find the equivalent resistance of those 3 resistors, 2, 3, and 4, and draw the circuit diagram where they've been replaced with a single resistor. Once I have done that, then I note that there are only 2 resistors in this diagram, the original resistor 1 and the equivalent resistor 2, 3, 4, and then I'll draw them all, and since these 2 are now in series, I can replace them with an equivalent resistor, what I'll call 1, 2, 3, 4, meaning that it's composed of all 4 of those resistors. Now, I need to find the equivalent resistance 1, 2, 3, 4 so that I can find the equivalent resistance 1, 2, 3, 4, which is the equivalent resistance I'm talking about, because that includes the entire segment. So I have resistors, and these 3 are in parallel, which means that you have to use the formula for parallel resistors. Remember, this one is the reciprocal case, unlike for capacitors, where parallel means you just add up the capacitances, resistances, you add the reciprocals. So I get 1 over 10 ohms plus 1 over 30 ohms plus 1 over 5 ohms. In other words, I can do this a couple ways. I can plug this into my calculator. I can add up find the least common denominator and then multiply appropriately, add them all up. I'll do that one in my head here. So the least common multiple is going to be 30 in this case. So this is 3 thirtieths, 1 30th, and 6 30ths. 3 plus 1 plus 6 is going to be 10. So I have 10 30ths, 10 over 30 ohms. And note that this is not the actual equivalent resistance. This is 1 over the equivalent resistance. So if I want to find the equivalent resistance, I have to invert it. So 30 over 10 ohms, or just 3 ohms. And note that this value is smaller than the smallest of these resistors, which is good. It's less than 5, which is qualitatively correct. Now what I need to do is add these 2 resistors together, and the equivalent resistance 1, 2, 3, 4, since these are in series, I'll use the series formula, where I then now just add the 2 resistances together, and so I have 8 ohms plus 3 ohms, and overall I get 11 ohms.